Good evening, and welcome to the Ask and Learn Geothermal Education Series, presented by GeoComfort. Today's session we're going to cover, how does geothermal work where I live? A very popular question for us. Geothermal can work in a variety of settings. So today, I'll be your host. I'm Kyle Smith, also the moderator. I work in Intertech Global. Then your presenter is Tim Wright. He is also from Intertech Global. Intertech's been around since 1996. Our factory is actually in Mitchell, South Dakota, with our corporate headquarters in Greenville, Illinois. We sell products throughout the United States, Canada, and beyond. Residential and commercial customers are our focus, and I'll pass it over to you, Tim.
All right. How to make the most out of this webinar? We would just encourage you folks this evening to feel free to take notes. Feel free to ask any questions. And as you'll see over on your right-hand side, you'll have a little window that allows you to write or draft your question in there and then submit that. And then Kyle and I will take turns at the end of our session together, and we'll answer those questions for you. And then we would also encourage you to spend time in your continued research on geothermal heating and cooling technology, and feel free to review geocomfort.com. So to get into the geothermal webinar this evening, we'd love the opportunity to just go through this with you. Some of this you may already know, but maybe for some of you on the webinar, on the call tonight, maybe this is new. So geothermal really is, another term is solar thermal, or really getting a lot of our heat energy from solar energy. So what does that mean? That means as the sun continues to shine down on the earth, approximately 48%, or almost half, of all of the heat from the sun is absorbed into the ground. And the earth operates now then as our solar battery, absorbing all of that heat energy into the ground. So as we take a look at it as a heat source in the wintertime, again, please remember with me that that heat energy has been absorbed into the earth all summer long, and very much acting like a battery as we come into the wintertime, even as the screen shows a -20 or in that area, obviously very cold temperature, we are taking the earth's heat. So that geothermal system is actually pulling the heat from the earth, or we're transferring it from the earth back up into your space, whether that be your home, your workshop, your church, your school. Either way, there is so much of that heat energy that is from the earth being brought back into your space. And keep in mind, and we'll show you a slide here in just a minute, that ground temperature typically stays between 40 and 75 degrees Fahrenheit below that initial 4 or 5 foot of the earth crust surface. So now let's take a look at the opposite. So as we're looking for a cool indoor environment, keep in mind heat always moves to cool very, very quickly. So on a very warm summer day, 95 degrees outside, and we're trying to condition the space, whether it be a home or, again, institutional facility, to say 75 degrees Fahrenheit, what we're doing then is extracting the heat out of our structure and then displacing that into the cooler earth. And keep in mind, if for those of you that have ever seen a blacksmith do their work, as they're heating up the iron, what do? Do they wave it around in the air for it to cool down? No. They actually stick it into a bucket of water for instant cooling. So it gives you a perspective that water is so much better of a heat transfer medium than air is. So that's why geothermal heating and cooling systems can operate because we're dealing with ground temperatures. We are not dealing with air temperatures. So let's take a look at that soil study that I had shared with you. So as you look across the United States of America, ranging all the way from the very north, which you see in a purple color, if you will, about 35 degrees Fahrenheit as an average soil temperature, all the way, say, to the tip of Florida, down in your Miami area, where that average temperature is about 77 degrees Fahrenheit. But take a look across the breadth of the United States, and you're really ranging between 42 and about 57, 62 degrees as an average. So that is a very, very fantastic temperature to be able to either move heat to your structure or take heat away from your structure to the cooler earth. So as we take a look at some ground loop options, or some closed loop options as people sometimes refer to it as, there's many different ways of, again, whether your structure is residential or commercial application, many of those opportunities have a pond, maybe nearby. And if you have a pond nearby, then the polyethylene pipe can be laid in the bottom of that pond. And again, that would be your heat source or your heat sink for your heating and cooling needs for your structure. Let's take a look at another option, a horizontal loop system. These are typically buried about 5 to 7 feet below grade. And again, this is in a horizontal capacity. So you'd certainly need a little bit more land in order to do this type of loop technology. But typically you're now just dealing with a backhoe, or you're dealing with a horizontal bore machine, which tends to be a little less expensive on the installation of that loop system. Let's also take a look at the vertical bore. A lot of times, whether it be a commercial application with limited space or a very small, tight city lot, your vertical bore closed loop system is a wonderful way to limit your space that you truly need in order to get to that Earth's temperature to heat and cool your structure. So just here's a brief overview. The pond loop, the vertical loop, the horizontal loop, these are all different methods of bringing the heat in or taking the heat away from your structure. Keep in mind, with geothermal technology, you typically are, for $1 worth of energy, you are getting between $3 to $5 of energy in return. So let's take a little closer look at the geothermal system. So you have a unit that would obviously be in your structure. You also have a flow center or a pumping station that you see off to the left. And then you also have your loop system, which we've buried in the ground as we've shared with you the different loop configurations. So with that as your technology, you really have 3 basic components that you're bringing all together. Now keep in mind one thing that you don't see, and that's a unit sitting outside. With your geothermal system doing all your heating and cooling needs, you do not have any condenser sitting outside that's battling the weather. So what about my home? Geothermal works here. Let's take a look at this. So it's often asked of us, well, is it just for new construction? The answer is no. I would say roughly 50% of our business right now is heading back toward new construction with geothermal going in those homes, but the other 50% would be existing structures. Again, homes, schools, doctors' offices. So it's just a wonderful opportunity, irregardless of whether it be new construction or existing structures. Geothermal can fit in there quite nicely. Now let's take a look at that up in your top right-hand corner. Does it have to be a certain square foot? Once again, the answer is no. We have some very small homes that we're doing down in Arkansas right now that would not even be 1,000 square foot that are going all geothermal, all the way up to your much larger structures or larger homes where geothermal systems can either be done individually, or you can have multiple geothermal systems in your structure to help you with your heating and cooling needs, as well as helping with your domestic hot water applications. What about other structures? Boy, let's take a quick look at that. The implement shed that you see. the garages, the churches. Wonderful opportunities for heating and cooling with geothermal. And what do you see? Again, very nice, neat, tidy outside applications with no outdoor equipment whatsoever when you go with geothermal heating and cooling. So thank you for taking time to join us, and I'm going to turn this back over to Kyle this evening.
Thanks, Tim. Nice job. Thank you very much. So let's take some time to enter in some questions into the sidebar. Do you have any? We'll take this part slow so that you can have some time to input. Next, take some time to visit us at GeoComfort.com and use our savings tool, or you can find a deal in your local area. If you'd like to actually talk to me or Tim, go ahead and give us a call at 618-664-9010 or at our email address you can see on the screen. Next, this video will actually be recorded, and you can find that on our YouTube channel. The address is below. Okay, Tim. Oh, and then in January, actually, we have a full schedule of webinars coming up throughout the 2016 year, so please check back on the website. So we have a couple questions here, Tim.
All right, Kyle.
So let's go with the first one. Somebody says, we're between making improvements to our current house or building new. Anything we should consider?
Wow, Kyle, that's a very good question. I guess first of all, how I would answer that is, as we've discussed this evening, geothermal fits into any structure. And I think the biggest opportunity that I would recommend is whether you're looking at renovating your existing structure, I would always focus on your building envelope first. If you have any additional improvements that you can make, like new windows or adding additional insulation to either an attic space or wall or basement area, that is always the best use of your resources and your money and your quickest return on investment. Once we have that achieved, now all of a sudden, Kyle, we can be looking at a smaller system. And why is that important? The systems are all rated in tonnage. And if there's any way possible to do this with, say, a half a size less or one size less, that saves the homeowner a considerable amount of money. Generally speaking, considerably more than even what their energy efficient improvement would have cost them. So again, a much quicker return on your payback, if you will. Now take this over to the new construction side, Kyle. You can't go wrong putting geothermal in any new home. With the rates, I'll say mortgage-wise right now into the 5 or 4 or 3% range. On average, you're looking at between $4 per thousand to borrow right now. So even an additional $10,000 for a geothermal system might cost you $30 to $50 a month additional on your mortgage payment, which you would certainly have a much higher return of energy savings just on that side alone.
Good points, very good points. All right, how about the next one here? We live in Maine and on the coast. Could Geo help us out here?
Wow, first of all, Maine, absolutely beautiful area, but that is certainly a mixed bag of weather patterns throughout there. Seasonably, that would be a heating dominant market, Kyle. So with that in mind, certainly geothermal would be a wonderful option. And as we look toward, more heating dominant locations, it's easy to really have geothermal be a strong payback. Typically in that 4 to 7 years, they would have their return on their money. And that, when I say that, that's just looking after the incremental difference of replacing another system for like, compared to paying a little bit more for geothermal, but having your return on investment. Again, those temperatures in Maine are going to get very, very cold in the wintertime. This may sound a little bit like a silly example, but I've certainly used this before. But even for those that have flown across the United States, the average temperature at 30,000 feet is minus 47 degrees. And how thick are the walls of the jet airplane? Only about 2 inches. So again, it comes back to building performance, building it right. If you have a new construction or an existing home, making sure you spend your money on your improvements to have a better system in the long run.
Perfect. And it keeps the unit inside the house, so you don't have any of those salty air contaminants affecting the system, so the longevity goes through the roof.
Absolutely, Kyle. Any of those East Coast, West Coast, any of the coastal environments. Great point.
All right. Here's our last one. It gets really cold here. I heard heat pumps can't keep up in the deep cold. Do we need a backup?
That's an excellent question, Kyle, and I'm going to answer this two ways. Is if somebody is considering geothermal that already has propane or has another system, we have what we call dual fuel systems. So what we're doing there is we're not abandoning the system that they have in place right now, but we're actually just adding geothermal to it. So your geothermal system being as efficient as they are, again, for $1 worth of energy in, $3 to $5 of energy in return, we always want to use geothermal as your primary source. But if it were to get down to those extremely cold temperatures that we're looking at or you're referring to, then their backup, their propane, would only come in and cycle as a supplement because it's never going to be as efficient as your geothermal system. So that's on one hand, if you've got a dual fuel. Now let's say you go to the other extreme and you've got something that's just run down and you're going to change the heating and cooling system anyway. Then the geothermal systems are sized and designed to actually be right in that sweet spot. And we can certainly do a GeoAnalyst or run some software for folks that would be interested in this. And we can tell them exactly at what outdoor temperature or what balance point that they're going to need a little bit of supplemental heat. And that's okay, because again, keep in mind you want to size the geothermal system properly because it is your heating and air conditioning system. You want to make sure, and especially with two-stage compressor technology, we can get the best of both worlds. A lot of BTUs for their heating, and then also a little bit for their air conditioning come summertime so that we can really dehumidify their space well and air condition their structure beautifully.
Great points. Great points. Absolutely. It's all in the design, isn't it?
Yes, it is, Kyle.
Okay, well, that will wrap it up for our questions today and our webinar. Please check back as we'll be continuing to do more webinars. And if you'd like to talk to us individually, please give us a shout or shoot us an email. With that, we're going to conclude. And thank you very much for joining us, and we'll talk to you soon.
Thank you very much.